CSV export crashed the server every time. 6 GB peak memory for a 3 GB file, the container only had 4 GB. What broke? The endpoint built the entire CSV in memory before sending a single byte. Let's break down FastAPI streaming responses and file responses, how it works, and the exact mistake behind that failure. Streaming response sends data as it becomes available, without loading the entire payload into memory. FileResponse uses the OS sendFile syscall for zero-copy file serving. Both prevent memory exhaustion under load. Returning a list or dict builds the entire response body in memory. For large payloads, this is a disaster. Streaming response sends data as it's produced, keeping memory flat regardless of response size. Here's a basic streaming CSV endpoint. The generator yields rows one by one, and streaming response sends them as they come. Notice we set the media type and content disposition header manually. FileResponse uses the operating system's sendFile to transfer data directly from disk to network, bypassing Python's memory entirely. It also handles HTTP range requests for pause, resume, and video seeking. Here's a file download endpoint using FileResponse. It automatically sets content type and content length and handles range headers for free. Just pass the file path and optional file name override. For real-time dashboards or log streams, you can stream JSON objects separated by newlines. This is JSON lines format. The client parses each line as it arrives. This endpoint streams events as newline delimited JSON. Each event is serialized and yielded with a newline. The media type is application/xnd.json. Streaming has sharp edges. If your generator raises an exception, the client gets a truncated response. Proxies like Nginx may buffer the entire stream. Always wrap generator logic in try except and log errors. This safe generator catches exceptions, logs them, and yields an error message to the client. Note that the HTTP status is still 200, so the client must parse the error from the body. FileResponse is for static files on disk. It's zero-copy and handles range requests. Streaming response is for dynamically generated content. Never read a file into memory just to return it as a response. Streaming responses can overwhelm slow clients. Use an asyncio.Queue with a max size to implement backpressure. If the queue is full, the producer waits. This pattern uses a bounded queue. The producer waits when the queue is full, providing natural backpressure. A sentinel value signals the end of the stream. This is the same issue we highlighted at the start. Here's exactly why that happened. The endpoint built the entire CSV in a list of strings, then joined them into one giant string. For a 3 GB CSV, that meant 3 GB for the list plus 3 GB for the join string, totaling 6 GB peak memory. The container only had 4 GB, so the OOM killer struck. Building entire CSV in memory as a list of strings and joining them caused 6 GB memory usage for a 3 GB CSV, OOM killing a 4 GB container. Replacing response with streaming response yields rows one at a time, dropping memory to under 50 MB. The fix was to replace the response with a streaming response that yields CSV rows one at a time. Memory dropped from 6 GB to under 50 MB. We also added a content length header by pre-calculating the size from the database count. This is the exact mistake from the incident. Joining all rows into a single string doubles memory usage. Always use streaming response for large data. Without content length, clients can't show download progress and proxies may buffer the entire stream. For large files, pre-calculate the size and set it in headers. Never use blocking calls like timesleep or requestSget inside an async generator. They block the entire event loop. Use asyncio.Sleep and HTTPX, async client instead. Never use an unbounded asyncio.Queue in a streaming producer. If the client disconnects, the producer keeps filling memory until OOM. Always set a max size and handle queue full. The streaming response class is part of Starlette, which FastAPI depends on. In Starlette versions before 0.14, streaming response did not accept an async generator directly. You had to wrap it with iterate in threadpool. If you're on an older FastAPI/Starlette, ensure you're using Starlette equals 0.14 or use async def generators with StreamingResponse correctly. Check your versions with pip show Starlette. The article mentions using a database cursor, but doesn't show code. Here's a concrete example using async SQL to stream rows from a large table without loading all into memory. The generator yields each row as a CSV line, and the response streams it. The article mentions proxy buffering briefly, but it's a critical production issue. If you use Nginx as a reverse proxy, it buffers responses by default. For streaming to work, you must set proxy buffering off in your Nginx config or add the XXL buffering, no header from FastAPI. Otherwise, Nginx will buffer the entire stream before sending to the client, negating the memory benefits and increasing latency. Use these commands to diagnose streaming issues. Check download size, headers, logs, and system calls to find the root cause. Let's run through some common interview questions. How does FileResponse handle range requests? Uses OS sendfile and seeks to offset. When to choose StreamingResponse over FileResponse? Never for static files, always use FileResponse. What happens if client disconnects midstream? Generator raises error. FastAPI cancels it. And a few frequently asked questions. How to stream a CSV from a database? Use async generator yielding rows. What's the difference between FileResponse and StreamingResponse? FileResponse uses sendfile, StreamingResponse uses generator. Can I set content length on StreamingResponse? Yes, pass it in headers. To recap, never build the entire response body in memory. Use StreamingResponse for dynamic data and FileResponse for static files. Always wrap generators in try-except and implement backpressure for production systems. Ready to go deeper? Up next, FastAPI Async SQL Alchemy, then FastAPI Cloud. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.